Hello guys, welcome to Jagged. Today's episode is about PowerShell and we are on episode number 2. Today we're going to cover the following topics and I hope you do enjoy them. We cover from beginner to advanced topics, so please do subscribe. This is how pipelines work in PowerShell. So you've got a variable declared here. It gets all the files from this folder and stores them as objects. So everything is stored as objects in PowerShell. So this variable is now going to hold all the properties of these files within here. Then the next thing is we're passing these files, which are objects, to the next function or command let. And then this function basically takes the output that we had here and that variable is passed into the next command let. And then it takes a condition. This condition is declared using these curly braces. Then you're going to process each item. So by using $_ and the length. So how do I know its length? Because as you get with IntelliSense, these are all the different properties that you can do. And one of them is called length. So here we go length, and we're going to say anything that is less than 1 MB, filter those files out, store them in this variable here, and then show the small file. If I run this code, then as you can see, we've got the output here. I've got 2 text files here, which are less than 1 MB. But what you can do is you can simplify this code so you don't have to declare these variables and do it in one line. So here, pipelining the output from here into the next one and then displaying that. So if I run this line now, we got pretty much the same output. But you can see it printed some additional information such as the directory, the headers, and so on. If you don't want any of that, you can simplify it even further. So output from this one, the filtered list, will now get passed into the next one. So here, select object and expand and full name. The expand property, what it basically does is all these filtered lists are objects. If you didn't use the expand property, basically would get print out like the header and so on with it, but we just want the name. So I'll show you what that looks like. So if I run this, and as you can see, we just got the names, the file paths that are outputted here. Yeah, this is how you use pipelining in PowerShell, one to the other. Then finally, we use this expand property to print out the raw output. Now, if you didn't use expand property, then the output that you will get is the following. So if I copy this line and paste it here, and if I didn't use expand property, if I just did this, this will still be an object. So here we're just basically selecting from that entire object. If I run this, and as you can see, we now get the header printed here. Probably not what you want if you're outputting it to a text file, but what you can do is if you're passing it as an object to another command let or a function, it's best to pass it as an object. But if you just want raw output, then it's best to use expand property. In PowerShell, you can create an array like this. So here we're creating an array of numbers. You use the @ symbol and then open brackets here, or you can use this syntax, which is without using the @ or the parentheses, and this will also create an array. This is what my variable is called, and then you can get the element with the syntax, which is similar to other programming languages. You can write the output, so this is going to be the first element, which is 1 over here. You get the output here. And if I do the last element, notice the -1, so it will go in reverse. So this is -1, this will be -2. So if I run this, and as you can see, we now get the last element, which is 5. And if I do -2, we will get the second to last, which is 4, and then we get a 4 here. And you can get a list of a count of the elements within your array. So here, you can see we have 5 elements here. There you go, 1, 2, 3, 4, 5. And this is how you create array in PowerShell. So that's my variable name, use the @ symbol, or you can use this alternative syntax. And then you can navigate your array with the index numbers as shown here. Negative numbers to go in reverse, positive numbers to go from beginning to the end. In PowerShell, by default, arrays can accept multiple data types. So here you can have a string, an integer, a boolean, and a float. And you can add new elements by using plus equals, and this will append this additional element right at the end. And then if I run this code, you can see I'm using -1 to print the last element. So if I run this, and you can see here that we got this hello, which is a string, an integer, and the last element that we added at the end. So by default, PowerShell allows you to have different data types in your arrays. If you want to be strict and only allow, for example, integers, just before your variable name, you need to put the following. So this is open square bracket and close square bracket. And within here, you declare an integer data type, which is what we want. And then open bracket here and close bracket. And this will only accept integers. So if I run this without adding in the string type, just to show you. So now our array only has integers. But if I try and run this line here, and you can see we've got an error, and the error says cannot convert the value by to a type integer system 32. So here we cannot do that, and this has restricted what our array allows. So this is known as strict data typing in PowerShell, and this is how you do it for an array. This is how you create a 2D array in PowerShell. First of all, why is it called a jagged array? It's called jagged array because it can have different lengths. So as you can see here, the number of elements or columns in this is higher than the one in here. And you can see I'm using the @ symbol here to create the array. And we have 1, 2, 3, 4 columns in this one. Here we only have 3 columns and we have 3 rows. So this is known as a 2D array because we can access the elements like this. That's the first dimension and that's the second dimension. So this is rows and this is columns. So if I run this code and just show you what this looks like. So as you can see here, we've got the following output. We've got output of 1 here, and this is because it's referring to the first row and the first column, which is this. And then we've got the output of 7 here. And the reason we got 7 is we are referring to the first row and the second element. Now it is 0 index based. So this is row 0 and this is row 1. And I'm accessing the second column. So again, 0 index based. So it's 0 and 2, which gives you a 7. So this is how you work with 2D arrays in PowerShell. But remember, they are jagged arrays, so they can have different lengths in terms of number of elements within here. There is a way to create a true 2D array, which would mean that they would have the same length in terms of columns and same number of rows. That would be known as a true 2D array, and we'll cover that in another video. But jagged arrays are really flexible because you can do things like this, or you can make them the same length by just adding another element in here, and then they will be the same length. So this is how you can create a 3D array in PowerShell. So as you can see here, this is the syntax for it, but how does a 3D array look like versus a 2D array? So I've got a diagram here. 2D arrays essentially have this shape. You can imagine it like an Excel worksheet. So it's got rows here and it's got columns going across. And 3D array is basically one sheet and then the second sheet and the one behind it. So this is the first sheet. So you can see it's got columns going across and then it got rows going down here. And you can see, so that's one of them there. And then behind it is another sheet. So just like in Excel, you can have 2 sheets, 3 sheets. So in this instance, 3D arrays have 1, 2 sheets. This is the first sheet and this is the second. In PowerShell, you use the @ symbol and then open bracket, close bracket. So that's, you can imagine it as your first sheet, the first dimension. And then within here, you've got another dimension here, what's within the first sheet. So you've got 1 column here, second column, third column, fourth column, and then you've got 3 rows here, 1, 2, 3. So you can see the shape here. If you imagine this, these are the rows and these are the columns. And the same here, second sheet, you can see the same layout, first column, second column, third, fourth, and then you've got 3 rows here. So this is what is the shape of this will be 2 sheets or here, and it got 3 rows, 1, 2, 3, and it got 4 columns, 1, 2, 3, 4. And this is what the difference is. With a 2D array, you would only end up with this part of the code. So you wouldn't have a second sheet as such, like in the Excel example. So you would only have 1 sheet, and this is the second one. And then you can access the elements like this. So you can access, this is the, so it's 0 index based. So this is the 0 element. So this will be this one, and this is 1. So that's the second one over here. And then you're accessing the first row, so that would be 0 and row 1, and then you're accessing the second column. So if we start here, 0, 1, 2, so that's 7. So if I run this code and let's see if we get 7, and as you can see here, we did get 7 at the output because that's what the indexing here is referring to. And same with the other one, we're accessing the first sheet. So remember, it starts off at 0, so this will be 0 here, 0, and this will be 1, and then we're accessing the second row, so that's 0, 1, 2 as the second row, and we're accessing the first element, so that'll be 21. If I run this code now, and as you can see, we get the answer 21. So I hope this makes sense. So this is what the 2D array looks like, and this is what the 3D array looks like. And this is how you access and create a 3D array in PowerShell. In PowerShell, you can create a true 2D array by using the .NET object. So here we are creating a .NET array. The syntax of it in C# would be like this. So you declare your variable here, matrix, as an integer or type array, and then you say new int and then specify how many rows and columns that you want. And you can use that in PowerShell like this with the new object syntax. So new object lets you create .NET objects, and you supply it that you want to create an integer, new integer array, and then you specify the requirements like this. Notice the difference in syntax. This is something that you just need to get used to. The reason for supplying these in single quotes is because it contains square brackets. Otherwise, it will cause an error if you don't do this. So you just need to supply it in single quotes, and then you will get a true 2D array. And what I mean by true 2D array is in PowerShell, you can create arrays of arrays. So this is an array. This is known as a jagged array. So you can see within here, we can have a second array, but the elements can be jagged. So what I mean is, for example, we could delete this, and this would have 3 elements while the others here have the 4 elements. So by creating a true 2D array, you get the same number of columns, the same number of rows, while with this syntax, you can actually have a jagged array, which is of different lengths for elements. So here, the second row actually only contains 3 columns, but with a true 2D array, you cannot do that. It has to be the same length. And then you can access the elements like this, whereas previously you access the elements like this. Notice the 2 square brackets here. And here we're just using a single square bracket, and we're using comma to separate the row and the column. So it matches the C# syntax essentially. So here we're assigning the values to this array, and you can see when we output the values here, we can see that the output is 1, and we can see that over here because that's what we assigned at position 0, 0. Alternative syntax that you can use is by directly using the .NET type, but you don't have to use the new object. So here you can create a .NET object like this. So again, you can see very similar syntax. We're using the .NET integer class, and we're creating a new array of that integer class with 2 rows and 3 columns. These columns here are basically accessing the static initializer of the integer class, and we're creating an array out of it. So here you can again access the same thing. So the concept of accessing the elements stays the same. And again, if I run this, and you can see that we get the same output as before. So 2 different variations in syntax, either using the object directly like this, or you can use it like this. This is only compatible in newer versions of PowerShell. So that's, I think, from 5.2 onwards, and this is accessible in the older versions of PowerShell. So this is how you create a true 2D array in PowerShell using .NET, while here we are creating a jagged array, which is also known as arrays of array. So here, this is a nested array, and they can be jagged because they can have different lengths, while here a true 2D array will have the same number of columns and rows. In PowerShell, you can create Microsoft Excel documents using automation. So here we're using a variable called Excel. This will basically store the reference to the Microsoft Excel program. And here we are using new object, so equals new object. And the new object basically lets you create any application, whether it be a .NET or an older version, which is like COM object, which was developed as part of Microsoft Windows. So here you just add this switch parameter COM object and then type in excel.application, and this will let you create Microsoft Excel file. Now when it creates it, it will be hidden, but you can set it to true. So if I run the first line here, I've run that line, and now I run that variable name that we had here, excel.visible.assign excel.visible. And if I run this here, you can see the Excel have become visible. And then I can hide Excel by doing hide. So here, Excel is hidden, and I can enable it again, and you can see it's come back. I can add any worksheet like this. So you can probably recognize this code if you have used VBA in Microsoft Excel. So if I run this, you can see any sheet have been added in. So that's a new workbook, and I can add a new sheet which have been added in, and then I can work with the sheet here. So you can see where the header that's gone in, cell item 11. So that's the reference to the first column, first row. And then here I can do this. So you can see if I run each line, what's happening. And then what I can do is I can go over here, and this is, let's say I wanted a list of files within this directory. So within my projects and PowerShell. So if I run this $sign files, and this will now store all the file paths here. And then I can go to the second row within Excel. So this is without row. So that's just a variable to store the row number, just a count. And then I can use this code to basically add in, loop through all the files and add them into Excel. So if I run this here, so you can see, there you go. You can see there all the files have been added in, and you can see it's added that information into an Excel file using for each loop. And then I can do save the Excel file if I wanted to. So here, so I can just go here, run this, and that's now saved the file in that folder. And if I run this again, so you can see what it's doing, and you'll see the new file has appeared here. And there you go, files list has appeared there because that's the one we saved here using this piece of code here. So save as an Excel file path, and then you can quit the Excel by running this command. And here is come up with a box because Excel is visible, but I could set it to force quit, but this time I will manually click save, and there you have it. And then you can release the memory that's been occupied by the variables that you used. So worksheet, workbook, Excel. So you can just run this. So system runtime marshal services release COM object, and we're just going to change them to null, and there you go. The memory have been released, and we can just write an output message to say Excel file is saved. So if you were to run this as one script, this will do it very quickly for you. Oh, you can do this. If I run this entire script, and you can see that it's done it, and you can see it's saying, do you want to replace the file? And yes, we do. And of course, we can disable that warning with the flags within this save as command here if we wanted to. So this is how you automate Microsoft Excel using PowerShell and using the new object and the COM object parameter here. And then you can do any application you want, including Word. So if you want in Word, you can just type in Word.application, and there you go. It will now do Word. So if I were to just show you that just quickly, ignore the variable name. So I will just show you that it does work. So if I run this, and you will shortly see Word open up, and there you go. Microsoft Word have opened up on my screen, and then you can continue to work with Microsoft Word using PowerShell. So this is a very familiar syntax if you have used VBA for automation. So you find all these very similar. The only new bit is you've got $sign as the variable name, but the rest of it is pretty much the same. And you can get syntax intelligence. So if I were to do this, for example, so notice that the variable is still called Excel, but it's Word. We know this, and you can see now when you get the intelligence here, it's basically all the Word objects that you see here. So you can see new document. You don't see Excel template or anything like that. You see Word template, so normal template, new document, and so on. So this is how you can work with any Microsoft Office application using new object, COM object, all in PowerShell. So just think of new object as a piece of tools that allows you to create or components of applications such as Microsoft Office, so that you create objects of any application that is compatible COM object.